Good morning. Am I audible? Good morning, all of you.
Good morning, sir.
Good morning. Okay, so we'll start with the lecture. Is PPT visible? Numerical one that we have already seen in yesterday's lecture.
Yes, sir.
Okay. So we have seen this numerical in yesterday's lecture. Part of this numerical is seen method one. That is using method one, of course, by using KVL, KCL, whatever are the rules. We worked in time domain form. We obtain model equations and then converted into the Laplace, that is the frequency domain, and then computed the transfer function yesterday. But what is the method 2? Method 2 is, I'll just compare the first circuit first. So here you can see Vi of t is there, then I of t is there, then V of t is there. Every say thing in this model or circuit is in time domain. But in method 2, what we can do, we can convert it into the Laplacian domain. That is, this is Vi of s, then current is I of s, then output is V of s, then R remains as it is. As it is a capacitor, it converted into 1 by SC. If it is inductor, it will be SL or LS, whatever. So likewise, you can convert all the complete model into Laplacian domain, and then you can write for the equation. So what I want now, I want the output, and we know the output is across the capacitor, and of course, whatever is the input connected will be dropped across resistors as well as capacitor, and my output is nothing but voltage across capacitor. So we will use simply the voltage division rule, that is whatever is the impedance of capacitance divided by total impedance. So here VO of S is computed like impedance of capacitor, that is 1 by SC, divided by total impedance, that is R plus 1 by SC, multiply by input applied, that is VI of S. Then VI of S is taken this side. So VO by VS, of course, VO by VI is nothing but transfer function. It will be 1 by SC divided by R plus 1 by SC. Reforming this, that is multiplying numerator and denominator by SC, then it will be 1 upon 1 plus SRC. So you can see the earlier say method, VO of S upon VI of S is nothing but 1 upon SRC plus 1, and RC is tau, so in time constant form it will be 1 by S tau plus 1. So we got similar answer with both the method. You may adopt any of the method to solve the transfer function numerical. We'll move to the next numerical, that is numerical number 2. So you can see here in earlier example there was input voltage and output was also voltage, but in certain cases there might be current as an output. So for the system or network shown in the figure, Vi of t is an input and I of t is an output, and find out the transfer function. So of course the transfer function is Laplace transform of output. Here output is current, that's why I have written I of t divided by Laplace transform of input, that is V of t. In Laplacian domain it may be written like I of S upon Vi of S. So current, output current divided by input voltage is here transfer function. So here again I applied method 1 where the circuit is in time domain form. So I applied KVL to the loop. There is only one loop. So what Vi of t is nothing but Vi of t minus resistance का drop, that is VR, minus inductor drop, that is VL, minus capacitor drop, that is VC, will be equal to 0. So Vi of S is equal to Vi of t is equal to VR plus VL plus VC. So we'll write in the form of current. These voltages are written into the form of current. So resistance में से current जा रहा है, that voltage will be I of t into R. Inductor it will be L di by dt. Capacitor it will be 1 by C integral of I of t dt. And then the Laplace transform is taken. That will be Vi of S is equal to I of S into R. Then SL into I of S, 1 by SC into I of S. Taking I of S common, it will be Vi of S is equal to I of S into R plus SL plus 1 by SC. This is equation number 1. And we need output upon input. So just changing the terms, output is current I of S divided by input is Vi of S will be equal to 1 upon R plus SL plus 1 by SC. Multiplying complete say term, numerator and denominator by SC, so it will be SC upon SRC plus S square LC plus 1. So generally we write higher order first, so S square LC, SC upon S square LC plus SRC plus 1. So this is the complete transfer function of the given system. So this is adopted, say calculated by method 1 where the time domain equation or model equations are obtained and later on it is converted into the frequency domain. But here second method you may directly adopt, that is Vi of t converted into Vi of S. I of t is converted into I of S, resistance as it is. Inductor will be converted SL and capacitor will be converted into 1 by SC. So directly you can write, of course same equation is required. Vi of S is equal to I of S into R will be drop across this resistance. Then another drop across inductor, that is I of S into SL. So drop across this inductor, and another drop across capacitor, that is I of S into 1 by SC across this, and rest of the things you are known to, just taking I of S common and getting equation for I of S by V of S. So you may adopt any of the method. So this is numerical number 2. If you have doubt or query at any point of any point, you can interrupt me. So numerical number 3, that is, if the given transfer function is transfer function दिया हुआ है, that is 1 plus 3s divided by 1 plus 9s, and the capacitor value is 1 farad here. Here is the capacitor. Then find out value of load resistance and R1 and RL की value find out करनी है. So you can see this is the circuit where 3 components are there. So instead of adopting method 1, method 2 will be very, say, convenient. So this circuit is converted into the impedances. Say Z1 is nothing but R1, and Z2 is nothing but series combination of RL and C. So converted into Laplacian form, that is VIS and VO of S. Then written equation for Z1 is simply R1, you can see here. What is Z2? Z2 is RL plus 1 by SC. Just adjusted this equation, 1 plus SCRL divided by SC. Then what is output? Of course, output is what? Z2 upon Z1 plus Z2. So it is Z2 upon Z1 plus Z2 is the output. So kept all the values here, Z2 की value here, Z1 and Z2 की value here. Then final equation we get 1 plus SRLC divided by 1 plus SR1 plus SRLC. Now we have given value of capacitor here 1 farad. So we'll put value of capacitor here, that is 1 farad everywhere. So putting the value of capacitor 1 farad into the equation, we get this equation 1 over SRL upon 1 plus S common into R1 plus RL. Now we are interested in finding out value of RL and R1. So randomly choose नहीं कर सकते हैं. You just see the given transfer function. It is 1 plus 3s divided by 1 plus 9s. So of course RL value is 3. If we use RL value is equal to 3, so numerator will be 1 plus 3s. So we'll put RL is equal to 3, and of course what I need below into the denominator, it is 1 plus 9s. So here 1 plus s is there, 9 लेने के लिए RL is already 3. So if we choose R1 6 ohm, then R1 plus RL will be of course 9. So putting the value of RL 3 ohm and R1 6 ohm, we get transfer function, given transfer function, that is 1 plus 3s divided by 1 plus 9. So here is the solution to the this third numerical. Maybe ask for 7 to 8 marks into the examination. Now next is another numerical, that is numerical number 4, where if in the given circuit R1 is 2 mega ohm, here is R1, R2 is 3 mega ohm, here is R2, C1 and C2 values are same, that is 1 microfarad here and here. Find out the transfer function. So again, looking at this circuit, instead of say applying KVL and KCLs, it will be quite tricky, and say you may make mistake. So we'll adopt second method, where circuit is converted into the Laplacian domain or frequency domain, where so this C1 and R1 in parallel is nothing but impedance Z1. C2 and R2 in parallel, sorry, in series is the impedance Z2, and input VI of t converted into VI of S, VO of t converted into VO of S. So let's calculate the impedances first, Z1 and Z2. Our aim is to calculate VO of S upon VI of S. So Z1 and Z2. What is Z1? As I earlier pointed, Z1 is parallel combination of R1 and C1. Laplacian में convert किया तो R1 as it is parallel to 1 by SC1. So adjusted this equation. So it will be R1 into 1 by SC1 divided by R1 plus 1 by SC1. So again further computing it, it will be R1 by SC1 divided by 1 plus SR1 C1 divided by SC1. So finally Z1 after computation, this SC1 get cancelled, and finally we get R1 divided by 1 plus SR1 C1. So this is the value of Z1. Similarly, we'll calculate Z2. Z2 is very easy because it is simply a parallel combination of R2 and series combination of R2 and C2. So it will be R2 plus 1 by SC2, Laplacian domain. So it will be 1 plus SC2R2 divided by SC2. Now, output voltage. Output voltage is what then? I made a mistake here. This typing mistake. So this is actually Z2. I'm sorry. And we know the transfer function V of S upon V of S will be Z2 upon Z1 plus Z2. So this is the value of Z2. That is 1 plus SC2R2 upon SC2. Now next is the transfer function is V of S upon V of S. So it will be simply Z2 upon Z1 plus Z2 because output is nothing but a Z2. So here putting the value of Z2 here and Z1 plus Z2 here, and finally computing this. I'll not go in detail here. Finally computing this, you please refer the PDFs which will be uploaded after this lecture. So putting all values and doing all calculations or say manipulations, here we get these terms. And after getting this term, there is one more thing that we have to do, that is we have to put the values R2 mega ohm, R2 3 mega ohm and C1 C2 1 microfarad. So putting all these values into the equation, we will have this 1 plus 3s into 1 plus 2s divided by s plus 1 plus 3s into 1 plus 2s, and multiplying this, finally transfer function will be 6x square plus 5s plus 1 divided by 6x square plus 6x plus 1. So after calculating transfer function and putting the values, you will get final transfer function like this. Then moving to the next numerical, that is numerical number 5. Find out the transfer function of the given circuit. You can see similar kind of circuits are there all now, just small changes. Some values may be different. Some parallel series combination may be at different places. So ultimately these are the RLC circuit. So we have R and L in series, and towards the output we have कैपेसिटर C. इसका हमें ट्रांसफर फंक्शन निकाला है. सो ट्रांसफर फंक्शन निकालने के लिए दैट इज ऑफ कोर्स V of S upon V of S will be Z2 upon Z1 plus Z2. The common say it is a general thing. Now what is Z2? Z2 is the capacitor voltage, and in Laplacian form or frequency domain we write it is 1 by SC, And what is Z1? Z1 is R plus SL. They are in series. So it is R plus SL. And again plus Z2 hai yahan pe. So that Z2 is nothing but 1 by SC. So we got the transfer function. We have to just say minimize the terms here. So 1 by SC divided by SRC plus S square LC plus 1 divided by SC. So SC get cancelled. Here VO by VI of S is nothing but 1 upon S square LC plus SRC plus 1. So this is the complete transfer function of the given circuit. Very simple example, maybe ask for 5 to 6 marks. Next is numerical number 6. Find out the transfer function of given circuit. Most of the numericals are taken from the university question papers. I have not mentioned here, but they are from university exam. Value of R is 10K. Value of L is 10 millihenry. Value of C is 100 microfarad in the given circuit. Of course, you can see the previous circuit is same. So whatever is the Laplace, say, transfer function will be similar. So it is Z2 upon Z1 plus Z2. Z2 is 1 by SC for capacitor. Then Z1 is series of R and L. It may be written like R plus SL in Laplacian domain. Plus Z2 is nothing but 1 by SC. Doing the same calculation, I'll not repeat, it is similar to the previous example. Only some values are given, those we have to put into the transfer function. So finally the transfer function VO upon VI, we get 1 divided by S square LC plus SRC plus 1. Then into this transfer function, putting the values, that is 10K R, 10 millihenry L and 100 microfarad C, putting all the values and doing calculations here. Finally we get 1 upon 10 raised to power minus 6 into S square plus S plus 1. So multiplying and dividing numerator and denominator by 10 raised to power 6. So finally transfer function will be 10 raised to power 6 divided by S square plus 10 raised to power 6S plus 10 raised to power 6. So this is the final transfer function after putting the values. Going to the next numerical, that is numerical number 7. Find out the transfer function of the given circuit. You can see just some changes are there. It is also RLC circuit, where here in this branch we have resistance and inductor in parallel and capacitor towards the output. So again Z2 upon Z1 plus Z2 is the transfer function, where Z2 is simply 1 by SC, which is the V of S, and Z1 is R plus LS, sorry, parallel combination. So it will be R into SL divided by R plus SL. So Z2 is parallel combination of this. So there is slight change here. So we'll calculate it. Z1 is R parallel to SL. Then it will be R into SL divided by R plus SL, and Z2 is 1 by SC. Putting the values of Z1 and Z2 in above equation, we get 1 by SC divided by R into SL divided by R plus SL plus 1 by SC. So changing the terms here and there, we get final transfer function R plus SL divided by S square LCR plus SL plus R. So finally we get the transfer function like this. If you think that I shall wait for certain time on particular PPT, as these are the numericals, you may be feeling it is say going very faster, so you may interrupt me. Otherwise, these PPTs will be available on Teams after this lecture, so you may refer it at that time. Next numerical, you can see somewhat complicated circuit. This is the circuit, this one, this is the circuit. Again, title is same, find out the transfer function of given circuit, means output upon input. So you can see this here, 1 ohm resistance and 1 Henry inductor, they are in series. 1 ohm resistance and 1 farad capacitor, they are in series, and this complete is in parallel, and at the output we have 1 ohm resistance and 2 farad capacitor in series here. So we have to be careful while solving this type of numerical. So what we do, we'll use, say, we'll convert it in some module. So I will just say that the series combination of this, whatever I am marking here, series combination of this is nothing but Z1 dash. So Z1 dash is this 1 ohm in series with 1 Henry. So in Laplacian, we write R plus SL. So it will be R is 1, L is also 1. So it will be 1 plus S only. Again, another you can see 1 ohm and 1 farad ka jo capacitor that is in series. So I'll call that is nothing but Z double dash 1. एक notation दिया है. So it will be R plus 1 by SC. R की value 1 and 1 upon C value is also 1. So it will be 1 plus 1 by S is the say value of this branch, I will say. Then, however, your Z1 dash means this and Z1 double dash are in parallel, this. So I'll do the parallel combination here. So Z1 is nothing but Z1 dash into Z2 double dash, sorry, Z1 dash into Z1 double dash divided by Z1 dash plus Z1 double dash. So Z1 dash ki value 1 plus S as we have calculated here, into 1 plus 1 by S as we have calculated here, divided by 1 plus S plus 1 plus 1 by S. Calculating that, it will be 1 plus 1 by S into S, sorry, plus S plus 1 divided by 1 plus S plus 1 plus 1 by S. So computing this, you will get Z1 only 1. Z1 is only 1. Now coming to the another branch here. So this one, this resistance and this capacitor is in series. So for that I will say it is Z2. So Z2 will be series of R plus 1 by SC. Putting value of C, that is what 2 farad here. So it will be 1 plus 1 by 2S. So now I have Z1 as well as Z2, and we know what is the transfer function. Transfer function is VO of S upon VI of S is equal to Z2 by Z1 plus Z2. Putting value of Z2 in numerator, that is 1 plus 1 by 2S. In numerator, I have Z1 value 1 plus Z2 value 1 plus 1 by 2S. Adjusting this, we get transfer function is equal to 1 plus 2S divided by 1 plus 4S. So this is how we can solve. Now you can think of method 1 and method 2. If you would have applied what KVL and KCL in time domain, that would be say more say complicated than this method 2, that is directly performing into the Laplacian form. Then the numerical number 9. We are covering all the numericals today because later on we'll be moving to the next point of this unit. That is nothing but modeling of the system, and later on block diagram reduction and signal flow graph. and we'll complete this unit in this month. Of course, we will have 4 lectures now, next Tuesday and Wednesday, and next to next Tuesday and Monday, Wednesday. So in this month, your unit 1 will be completed. Later on, Dekeka sir will be continuing with second unit. So numerical number 9. For a certain system C of t is what? Response, that is output, is an output, and R of t is an input, that is nothing but excitation. It is represented by the differential equation. Now ordinary differential equation यहाँ पे दिया है d square ct by dt square plus 5 d ct by dt square plus 8 ct. So this complete side is nothing but the output side. You can see c of t आया इसलिए equal to 2 d r of t by dt plus r of t. So as it is r of t here, so this will be input or excitation side. If this is not in the form, you please arrange into this form. Left hand side पे पूरा output term लाना है, right hand side पे पूरा input term लाना है. If it is not in such form, find the transfer function assuming all initial conditions are 0. So we know what is transfer function. It is a Laplace transform of time domain output and time domain input. So it will be C of S upon R of S. So we'll do that. We'll put d square by dt square is equal to s square. Put d square by d by dt is equal to s, and c of t is equal to c of s. Similarly, r of t is equal to r of s. Simple, very simple. In the differential equation we get यहाँ पे d square by dt square के जगह पे मैंने s square लगा दिया. So s square c of s plus 5s c of s plus 8c of s equal to 2s r of s plus r of s. Taking c of s common, in bracket we get s square plus 5s plus 8. On right hand side, r of s common, in bracket we have 2s plus 1. So transfer function is nothing but output, that is c of s, upon input r of s is equal to 2s plus 1 divided by s square plus 5s plus 8. Very simple. And this kind of problem comes for say 5 to 6 marks only, where there is no circuit. You have to just convert it into the Laplacian domain and obtain the transfer function. Then then the numerical number 10. If the system transfer function is दिया हुआ है, that is y of s upon x of s. Of course, if it is transfer function, y of s is definitely output and x of s is definitely input. Is s plus 4 divided by s square plus 2s plus 5. Obtain the differential equation representing the system. अभी हमें differential equation लेना है, which is of course in time domain. So what you will do? You will do the reverse process. So to do the reverse process, we'll cross multiply the terms. That is y of s will be multiplied by this complete denominator, that is s square plus 2s plus 5, equal to x of s input will be multiplied by the numerator, that is s plus 4 here. Then we'll put s square is equal to d square by dt square, s is equal to d by dt, y of s is nothing but y of t in time domain, and x of s is nothing but x of t in above equation, and we get d square y of t by dt square plus 2 dy of t by dt plus 5y of t is equal to dx of t by dt plus 4x of t. So in this way, the given transfer function is converted into the differential equation form. So maybe 3, 4, 5 marks, whatever. Then the numerical number 11. The impulse response, the unit impulse response of the certain system is found to be e raised to power minus 4t. It is in the form e raised to power minus 80. Determine its transfer function. So what is impulse response means? It is only C of t. C of t is e raised to power minus 4t. What is transfer function? G of s is nothing but C of s upon R of s. But you know, we have used this term impulse response, that is R of t. अगर आप बात करोगे, it will be delta t, and R of s, of course, Laplacian में it is converted into 1. So R of s is equal to 1. So this term is equal to 1. Therefore, your transfer function G of s will be equal to C of s. So C of s क्या है? C of s is nothing but Laplace transform of C of t. So G of s will be Laplace transform of e raised to power minus 4t. And इसका Laplace transform we know in the second lecture PPT. That is G of s is equal to 1 upon s plus 4. Again, 3 to 5 marks. So in this way, we got the transfer function for particular problem. Now I'll take pause of 1 minute. If you have any question, any query, any discussion you want to discuss with me, you may. Am I audible to all?
Yes, sir.
Okay. The numericals are very straightforward. Everything is given on the PPT. Still you have, if you have doubt, you may ask. Else I will go ahead. There are total 17 numericals, and I hope will be covered before 12 o'clock. If not, maybe continued in next lecture. No worry. Okay. I hope there is a proper understanding at your end, as there is no question. So numerical number 12. The inverse Laplace of transfer function in the time domain of a system is e raised to power minus 5t, while its u of t equal to 2. Determine its output. Problem definition हमें समझना is very important. So given data, your u of t is 2. Inverse Laplace transform of transfer function. So L inverse transfer function किसे कहते हैं हम? That is g of s is e raised to power minus 5t. An inverse Laplace transform of transfer function is nothing but, in time domain it will be g of t, of course. G of t will be c of t upon r of t. So g of t is e raised to power minus 5t. This is the given data. Then what is c of s? C of s will be g of s into r of s, because g of s is c of s upon r of s. So just, it is very simple. And g of s क्या रहेगा? इसका Laplace transform, it will be 1 upon s plus 5. e raised to power minus 80 के फॉर्म में है. e raised to power minus 80 is nothing but 1 upon s plus a. Here a is 5. Therefore g of s is equal to 1 upon s plus 5. And what is r of s? It is a step input e of t, that is 2. So इसको अगर हम Laplacian डोमेन में लिखेंगे, it will be, मीन्स अगर ये 1 रहता तो it will be 1 by s. It is 2, so that's why it is 2 by s. R of s is 2 by s. So your output c of s is g of s, that is 1 upon s plus 5, into r of s, that is 2 by s. So simply it will be 2 by s plus, sorry, s into s plus 5. Now we have to solve it. We have to solve it because what I need the output in time domain c of t. So this type of functions can be solved using partial fraction. So I may write by this rule, that is C of S is equal to A by S plus B by S plus 5. So 2 is equal to A into S plus 5 plus B into S. Put S value is equal to 0. So this term will be equal to 0. And we get A is equal to 2 by 5. Then I want to make this term is equal to 0, A wali term. So I'll put S is equal to minus 5. Then it will be of course 0. Then B will be equal to minus 2 by 5. So I got value of A, that is 2 by 5, and value of B minus 2 by 5. It is nothing but 0.4. So putting this value into the given equation, so it will be C of S, still we are in frequency domain, equal to 0.4. 0.4 is nothing but 2 by 5 divided by S minus sign इसका जो आया हुआ है 0.4 divided by S plus 5. This is in frequency domain. बट हमें आउटपुट निकालना है. सो फ्रीक्वेंसी डोमेन में आउटपुट है, एंड इन टाइम डोमेन में क्या रहेगा, 1 बाय एस का क्या रहता है, इट इज 1. 1 बाय एस इज 1. सो यू मे से rewrite this if you want, this one 0.4 by S. So it will be 0.4 into 1 by S. So 1 by S का inverse Laplace लिया तो it will be 1. So it will be of course 0.4 only. So 0.4. And what about this? This term minus sign लेने के बाद this term will be 0.4 into 1 upon S plus 5. And 1 upon S plus 5 is in the form of 1 upon S plus A. And we can convert it into e raised to power minus AT, where A is 5. So 0.4 multiplied by e raised to power minus 5t. So this will be in time domain form. So this is expected. So this is the output for given numerical. While solving such kind of numerical, you have to just remember certain, say, conversions and bit presence of mind while solving this problem. Otherwise, it is very easy. Next is numerical number 13. We are covering different forms of the numerical. The statement is, what is the unit impulse response of the system given below? So I have a system where R of S is the excitation input, C of S is the output, and system में दो blocks है. One is 1 upon S plus 1 and another is 1 upon S. So what is the output? C of S is nothing but G of S into R of S. And what is R of S? Unit impulse response बोला है. So R of S will be equal to 1. Therefore, your output C of S is nothing but G of S. Whatever is the system is your output. So I'll write here C of S is equal to 1 upon S plus 1. ये जो पहला block दिया है, into 1 upon S जो second block दिया है. So it will be 1 upon S into S plus 1. You can see we got similar to the earlier form. Your C of S is 1 upon S plus 1. To solve this again, partial fraction, C of S is equal to A by S plus B by S plus 1. So it will be 1 is equal to A into S plus 1 plus B into S. Putting S is equal to 0 will get A key value, that is 1. Putting S is equal to minus 1. So I'll get B value, that is minus 1. And putting into the equation, this equation A and B, C of S will be equal to 1 by S minus 1 by S plus 1. This will be in frequency form. In time domain form, you know that 1 by S is converted into 1, inverse Laplace transform, and 1 by S plus 1, this is the format 1 by S plus A, that will be e raised to power minus AT, and A is 1 here, thereby minus sign as it is, and this term is converted by taking of course inverse Laplace transform, will be e raised to power minus t. It is e raised to power minus 1t or e raised to power minus t, it is same. So it is in time domain. Again, for 6 to 7 marks. Such kind of problems may ask. Again, if this subject unit test, of course unit test वगैरह होगी, that will be objective type, and in that objective type such small examples may be asked for 2 marks, where you have to calculate the output response either in frequency form or in time domain form, and 4 options will be provided to you. Now next, numericals are somewhat different. Before that, we have to understand, if I want to convert some signal into another, what is the procedure? So here you can see some signals are there. Here is a parabolic signal. Is PPT visible to you? Because this PPT is important to solve further problem.
Yes, sir, it's visible.
Yes,
Yeah.
sir.
This PPT is of transfer function to signal response. Is it same on your device?
Yes,
Transfer
sir.
function of, yeah. So you can see there are certain signal that is parabolic, that is another is ramp, another is step, and another is impulse. So I have shown very, say, in shortcut way on single PPT. If I wanted to convert parabolic into the ramp, then parabolic जो भी आपका function है, mathematical function, you will derivate that. It will be converted into ramp. If you want to convert ramp into the step, again you have to derivate the ramp. You know, this is nothing but what t. ये जो line है, that is nothing but t is a ramp. If you derivate that d by dt say, then you will get step. And if you derivate the step input, then you have t को अगर आप step input को derivate करोगे, you will get impulse signal, that is delta of t. Now the reverse process, if you have, say, these signals, if you have delta of t, that is impulse signal, if you integrate this delta of t, you will get step signal. If you integrate the step signal with respect to t, then you will get ramp signal. And if you integrate the ramp signal with respect to t, then you will get parabolic signal. Okay. Why this is required? You have to remember this. Why this is required? Because you will be providing a block diagram where there are not similar blocks. One is impulse response, another is a step response. So you have to convert those into the similar forms, and later on you will be getting the solution. You cannot directly apply and solve as we did earlier. Okay, so that's why this PPT is very important. Please remember this while solving the further problems. So the numerical number 14, based on, of course, transfer function. So the problem statement of this numerical is given. The impulse response of the system y of t. एक सिस्टम है जिसका impulse response हमें मिला है y of t is -4 e raised to power -t plus 6 e raised to power -2t. What will be the equivalent step response? Impulse response दिया हुआ है, उसका equivalent step response उसी सिस्टम का हमें पूछा है. So given data y of t is this. To get the step response, क्या करना पड़ेगा? I'll go back to the previous PPT and I will erase previous ink here. Okay, impulse response है, दिया हुआ है y of t, हमें step response पूछा है. So we are going in this direction, और ये डायरेक्शन में मींस राइट हैंड साइड से लेफ्ट हैंड साइड जा रहे हो तो यू विल इंटीग्रेट, और लेफ्ट से राइट जा रहे हो तो यू विल डेरिवेट. दैट्स व्हाई यू प्लीज रिमेंबर दिस पार्ट. सो टू गेट स्टेप रिस्पॉन्स, इंटीग्रेट इट. सो स्टेप रिस्पॉन्स is nothing but integration 0 to t of y of t. Simple mathematical. Step response is equal to integration of 0 to t minus 4 e raised to power t dt minus t dt plus 0 to t integration 6 e raised to power minus 2 dt. Then putting the limit -4 outside, iska integration is what? Minus t e raised to power minus t divided by -1, limit 0 to t plus 6 आउटसाइड लेना चाहिए था, मैंने 6 लिखा नहीं मैंने. I have to write 6. I forgot that. Wait a minute. Am I right? Yes. I need 6 here. Yes or no?
Yes.
Yes, sir.
Yes. So while copying and pasting, I forgot it. So again highlighter 6 common. इसका integration with respect to time will be e raised to power minus 2t divided by minus 2 putting limit. So kept limit into the above equation and solving that, finally we get 4 e raised to power minus t minus 3 e raised to power minus 2t minus 1. So this is the step response. Now you can see there is a particular system. There is a particular system और सिस्टम को हमने अगर इम्पल्स सिग्नल दिया है तो ये रिस्पॉन्स आता है, और अगर स्टेप सिग्नल दिया है इनपुट को देन विल गेट दिस रिस्पॉन्स. लाइक यू नो द डायोड. डायोड को अगर हमने, या फिर इंस्टेड ऑफ डायोड वी मे टेक से अनदर एग्जांपल like you may take any example. Suppose it is diode. If I say provide a forward bias signal, then it will conduct current, and if the polarity is changed, it is not conducting current. So behavior is different for different signal. So thereby you have to be able to make conversion from say any of the signal from say impulse to step, step to ramp, or maybe to parabola. अलग अलग सिग्नल अगर दिए हैं तो you should be able to calculate the response. Next is the 15th numerical number, that is the impulse response. Wordings पे बहुत ध्यान देना पड़ता है. Of initially relaxed linear system, initially relaxed means initial conditions are 0, is e raised to power minus 2t u of t. ये हो गया impulse response. To produce a response of t into e raised to power minus 2t, the input must be. अभी क्या बोला है इसने? It is very say straight forward. ये जो है e raised to power minus 2t into ut, ये impulse response है. जनरली हम impulse response को शॉर्ट टर्म में IR कहते हैं. और एक दूसरा रिस्पॉन्स है सिस्टम का जो कि t into e raised to power minus 2t है. ये लाने के लिए what must be the input? पहले इसमें इनपुट दिया था, रिस्पॉन्स पूछा था, अभी इनपुट ही क्या है पूछ रहे हैं. So initially relaxed means all the initial conditions are 0. So y of x upon x of s is the system where g of t is e raised to power minus 2t into u of t, and y of t output क्या है? ये वाला t into e raised to power minus 2t. So convert it into, कन्वर्ट करने के बाद इट विल बी व्हाट? g of s will be, इसे लाप्लास ट्रांसफॉर्म किया है, and again e raised to power minus 80 वाला फॉर्मेट. So it will be 1 upon s plus 2. y of s will be, इसका क्या होगा लाप्लास ट्रांसफॉर्म? It will be t into आया तो it will be e raised to power minus 2t का आ गया 1 upon s plus 2, but इसके साथ t है इसलिए it will be squared. So it will be 1 upon s plus 2 whole square. So putting into the say equation where this is g of s equal to, this is y of s divided by x of s. So we got x of s, and x of s is 1 upon s plus 2. Therefore x of t inverse Laplace transform अगर लिया तो x of t is e raised to power minus 2t u of t. So this is how we can solve. So this will be your input. This will be your input to get this output. Problem is solved. Next numerical is 16. I already told you there will be two different systems, subblocks. So a controlled system whose response, step response is 0.5 into 1 minus e raised to power minus 2t. ये इसका स्टेप रिस्पॉन्स है, ये वाला, इसके बारे में बात कर रहे हैं हम. आई होप इट इज विजिबल. SR स्टेप रिस्पॉन्स कैस्केडेड टू the another control block whose impulse response is e raised to power minus t. ये कैस्केड किया हुआ है अनदर ब्लॉक से जिसका इम्पल्स रिस्पॉन्स है e raised to power minus t. What is the transfer function of the combination of this cascade? And of course transfer function will be y of s upon x of s, but you can see in this we have different responses. Here is a step response, here is the impulse response. We have to convert it into the same. So both the blocks in the system should be same. Therefore, converting step response into the impulse response. Step response को impulse response में अगर convert करना है तो we derivate it d by dt. So impulse response is nothing but d by dt of step response. So impulse response is d by dt of, this is the step response, 0.5 into 1 minus e raised to power minus 2t. So d by dt of 0.5 minus d by dt of e raised to power minus 2t. So it comes minus 0.5 into minus 2 into e raised to power minus 2t. So it will be minus minus get cancelled, 2 into 0.5 will be 1. So impulse response will be e raised to power minus 2t. Now your block is likewise, you have an impulse response, this is also impulse response, and another block is also impulse response, where first block impulse response is this, that is e raised to power minus 2t. Second block impulse response is this, e raised to power minus t. Now we may go for the transfer function. So here x of t and y of t hai, is a we have written x of t, first block का impulse response e raised to power minus 2t जो हमने अभी अभी compute किया है. Second block का दिया हुआ है e raised to power minus t, and of course g of s will be what, y of s convert किया है Laplace में upon x of s. So इसका क्या है, first इसका it will be in the form of e raised to power minus at. So it will be 1 upon s plus a is 2, so 1 upon s plus 2. इसका भी same form है, so it will be into 1 upon s plus 1, and finally the transfer function will be 1 over s plus 2 into s plus 1. And the last numerical will have 2-3 minutes for this. Later on, if you have any query, you may ask, else we'll finish. That is 17 number. Find the transfer function of unit step response. Unit step means u of t is equal to 1. This is the university question. For this system, y of t output is equal to 5 by 2 minus 5 by 2 e raised to power minus 2t plus 5t. इसका हमने ट्रांसफर फंक्शन लेना है v of s upon v of s. A Laplace transform of unit step input. Unit step input means it is u of t is equal to 1. इसका Laplace transform क्या आता है, 1 by s. So here इसे हम Laplacian form में convert किए हैं. So here y of s is equal to 5 by 2 into s minus 5 by 2 e raised to power minus 2t का Laplace domain, it will be 1 upon s plus 1, and 5t का it will be 5 as it is और t का रहता है 1 by s square. So 1 by s square. So it is in Laplacian form. So the transfer function g of s is equal to y of s upon input. You may write x of s or u of s. So y of s हमें यहाँ पे मिला है, we will put here, that is 5 by 2s minus 5 by 2 into 1 upon s plus 2 plus 5 by s square divide by input क्या है, input is a unit step. Unit step का Laplacian domain is 1 by s. So therefore u of s will be 1 by s. Computing that, nothing is rocket science here. Computing that, multiplying, whatever addition, subtraction that is done here. I'll not read all these terms. Minimize किया है जितना हो सके. And finally, you'll get transfer function is equal to y of s upon u of s is equal to 10s plus 10 divided by s into s plus 2. So this is all about the numerical, different variety of numerical based on transfer function. And here we conclude this lecture, and later on we'll start with the modeling of the system, which will be the new point from this unit. Any questions? I'll wait for 1 minute, else I'll disconnect this lecture.
Sir,
Yes. Yes. Only
yes.
30. Yeah, Bhagyashree.
सर वो जो लास्ट क्वेश्चन है उसके अंदर जो दिया है कि यूनिट इम्पल्स रिस्पॉन्स दिया है.
Yeah, you please tell me numerical number 17, last numerical.
Yes sir.
Okay, coming to that. Okay, this one.
हाँ, तो यूनिट स्टेप रिस्पॉन्स है सर, तो वो इनपुट कैसे हो गया? लाइक रिस्पॉन्स मींस आउटपुट ना.
नहीं, यूनिट स्टेप रिस्पॉन्स मीन्स यूनिट स्टेप अगर दिया है तो उसका रिस्पॉन्स जो y of t है. सिग्नल इज यूनिट स्टेप. फाइंड द ट्रांसफर फंक्शन ऑफ यूनिट स्टेप रिस्पॉन्स. यूनिट स्टेप इनपुट देने के बाद जो रिस्पॉन्स आता है, तो रिस्पॉन्स तो इसने दे दिया है, दैट इज y of t. आउटपुट दे दिया है, और ये वर्ड में हमें पता चलता है इनपुट इज यूनिट स्टेप, जिसका हमने कन्वर्ट किया लैप्लास इन में 1/s. स्टिल डू यू हैव एनी कंफ्यूजन?
नो सर, नाउ गॉट.
ओके. सो
थैंक यू सर.
हमें क्या किया है, इसने बताया यूनिट स्टेप इनपुट है, उसका आउटपुट ये है. सो हमें पता है कि ट्रांसफर फंक्शन इज आउटपुट अपॉन इनपुट. सो हमें अभी आउटपुट ये है, और ये जो बताया है स्टेटमेंट से हमें पता करना है कि इनपुट क्या है. सो इनपुट इज ऑल्सो लैप्लासियन डोमेन में 1/s. सो 1/s हमने यहाँ पे रखा है, जो भी इनपुट है. आउटपुट तो रिस्पॉन्स तो हमें दिया ही हुआ है, ये रखा है. और इसे पूरा मिनिमाइज करके फाइनली हमें मिनिमाइज, जनरली आप आउटपुट ऐसे रख के रखो कि मिनिमाइज फॉर्म में रहना चाहिए टू गेट कंप्लीट मार्क्स. नहीं तो यहाँ पे ऐसे ऐसे छोड़ के मतलब नहीं है. ट्रांसफर फंक्शन अंडरस्टूड होना चाहिए क्या है. तो if somebody asks you to find out poles and zero for this system, let me talk for half a minute. So इसके लिए अगर किसी ने पोल्स एंड जीरो निकालने को अगर कहा तो इट विल बी वेरी ट्रिकी. दैट्स व्हाई इट इज इन सम स्टैंडर्ड फॉर्म. यहाँ पे अगर आपको पोल्स निकालने को बोले तो व्हाट यू विल डू, यू विल पुट s इज इक्वल टू 0. सो 0 विल बी सिंपल पोल, and you will put s plus 2 is equal to 0. So it will be s is equal to -2. So -2 will be another pole. So it will be very easy. That's why generally जो भी ट्रांसफर फंक्शन आता है, try to minimize. Any questions? Okay, if no, thank you very much. The PPTs will be shortly uploaded, and we'll see next point in next week. Thank you.